Welcome to our comprehensive study of the Himalayan Ranges. In this first part, we are going to explore the fascinating geological history, the structural classifications, and the unique characteristics of one of the most dynamic mountain systems on Earth. Let's start with a broad overview. The Himalayas aren't just a single line of mountains. They are a massive series of parallel and converging ranges. They were formed by continent-continent convergence, literally two massive landmasses crashing into each other. While we usually think of them spanning India, Nepal, and Bhutan, their geological family actually extends into Tibet, Pakistan, Afghanistan, and even down to the Andaman and Nicobar Islands. Because they are relatively young in geological terms, the Himalayas have a weak and flexible structure. This makes them the most unstable landmass in India. They are constantly being shaped by internal tectonic forces, causing folding and faulting, as well as external forces. Fast-flowing rivers, which are in their energetic, youthful stage, carve through the rock, creating dramatic V-shaped valleys, rapids, and waterfalls. How do we actually know these are young fold mountains? One major clue is the presence of deep gorges. The mountains are rising so fast due to tectonic uplift that rivers don't have time to widen their valleys. They just cut straight down. We also see U-turn river courses and U-shaped valleys, which are telltale signs of past glaciation shaping this young, rugged terrain. Further evidence lies in the parallel mountain ranges themselves. The rock layers are compressed and folded, and because the system is so young, the ridges and valleys haven't been worn flat by erosion yet. Additionally, the continuous rising of the mountains creates incredibly steep slopes. This unstable terrain makes the region highly prone to landslides, constantly refreshing its rugged appearance. To understand how the Himalayas formed, we have to travel back 250 million years to the supercontinent Pangaea. Around 150 million years ago, Pangaea split into two massive landmasses, Laurasia to the north and Gondwanaland to the south. Between them opened a long, narrow body of water called the Tethys Sea. Over millions of years, rivers flowing into the Tethys Sea deposited unimaginable amounts of sediment into its basin. The Indian Plate, originally part of southern Gondwanaland, broke off and began a long journey northward. Eventually, it crashed into the Eurasian Plate. This monumental collision acted like a giant vise, compressing all those thick sediments that had been sitting in the Tethys Sea. The sediments were thrust upward, forming the towering Himalayas. The subduction of the Indian Plate beneath Eurasia also created major geological fault lines, like the main central thrust. As the Himalayas rose, a massive trough or depression formed just to their south. The new mountains gathered ice, birthing massive river systems like the Indus, Ganga, and Brahmaputra. These rivers carried immense loads of eroded rock and alluvium down the mountains, dumping it into the depression. Over time, this completely filled the trough and erased the last remnants of the Tethys Sea, leaving behind the vast, flat Indo-Gangetic Brahmaputra plain. Geographers broadly classify the Himalayan system into 5 major divisions. Moving from north to south, we have the Trans-Himalayas, followed by the towering Greater Himalayas, then the Lesser Himalayas, and finally the outermost Shualiks. Additionally, there is a 5th division called the Purvanchal, or Eastern Hills, which run along India's northeastern border. Between Tibet and the Ganga Plain lie 3 parallel ranges, the Greater, Lesser, and Shiwalik Himalayas. Together, they form a massive arc stretching about 2,400 kilometers. Interestingly, they are much wider in the west, about 400 kilometers across in Kashmir, and narrow down to just 150 kilometers in Arunachal Pradesh. Fascinated, the folding of these mountains is highly asymmetrical. This creates what geologists call a hogback topography, where the southern slopes facing India are incredibly steep, while the northern slopes facing Tibet are much gentler. Because of this, climbing Mount Everest is actually less physically challenging from the northern Tibetan side. However, due to strict climbing restrictions imposed by China, most mountaineers brave the much steeper southern slopes from Nepal. The Himalayas don't just gradually fade away at their ends, they take sharp, dramatic hairpin turns southward. These setting curves are called syntaxial bends. The western syntaxial bend occurs near the towering peak of Nanga Parbat, right where the Indus River has carved a massive gorge. The eastern bend mirrors this near the peak of Namche Barwa, marked by the deep gorge of the Brahmaputra River. Let's look at the northernmost division, the Trans-Himalayas. Situated immediately north of the Great Himalayas, this region lies mostly in Tibet, which is why it's often called the Tibetan Himalayas. It sits at an average elevation of 3,000 meters. Unlike the main ranges that span the whole country, the Trans-Himalayas are only found in the western sector, covering areas like Ladakh, Jammu and Kashmir, and Himachal Pradesh. The Trans-Himalayas contains several distinct ranges. The northernmost is the Karakoram Range, extending 800 kilometers from the Pamir Knot. It is home to massive peaks, most notably K2, the second highest mountain in the world and the highest in India. Just to its northeast is the high-altitude Ladakh Plateau. South of the Karakoram lies the Ladakh Range, running parallel to our next range, with a few peaks poking above 6,000 meters. Continuing south within the Trans-Himalayas, we find the Zanskar Range, which boasts an average height of 6,000 meters and anchors the mighty Nanga Parbat Peak. Further east into Tibet, the Ladakh Range branches off into the Kailas Range. This range is famous for Mount Kailas, a site of immense cultural and religious significance, and its southern slopes near Lake Manasarovar give birth to the mighty Indus River. Moving south from the Trans-Himalayas, we encounter the Greater Himalaya, also known as the Himadri. This is the continuous, towering wall of rock and ice extending 2,500 kilometers from Nanga Parbat in the west to Namcha Barwa in the east. With an astonishing elevation of 6,000 meters, this specific range houses the absolute giants of the world, including Mount Everest, Kanchenjunga, and Nanda Devi. Structurally, the core of the Greater Himalayas is made of hard crystalline rocks like granites and gneisses, topped with metamorphosed limestone. Like the rest of the system, it features steep southern slopes. There's some fascinating trivia here too. Nanga Parbat translates to naked mountain, named because it stands isolated from the cluster of other massive peaks. And Mount Everest is known locally by beautiful names: Sagarmatha in Nepal, meaning goddess of the sky, and Komolangma in Tibet, meaning mother of the world. Next in line is the Lesser Himalayas, or the Himachal. Sandwiched between the towering Himadri to the north and the lower Shivaliks to the south, this range is about 50 kilometers wide. The elevations here are more moderate, ranging from 3,500 to 4,500 meters. A key feature here is the stark contrast in vegetation. The steep southern slopes are barren because the angle prevents soil from settling, while the gentler northern slopes are draped in thick forests. Because the elevations are lower and the climate is more hospitable, the Lesser Himalayas are the most accessible range for human settlement and tourism. If you've ever visited a famous Himalayan hill station like Shimla, Mussoorie, Nainital, or Darjeeling, you are standing in the Lesser Himalayas. This range also cradles some of the most beautiful and culturally rich valleys in the region, including the Kashmir, Kulu, and Kathmandu valleys. The Lesser Himalayas go by various local names, depending on the region. In Kashmir and Himachal, the most significant is the Pir Panjal Range, which stretches for 300 kilometers and is sliced through by rivers like the Jhelum and Chenab. Further southeast, it becomes the Dauladhar Range, passing through Dharamshala. In Uttarakhand, you'll find the Mussoorie and Nag Tibba ranges, which continue into Nepal as the Mahabharat Lek, and all the way into Arunachal Pradesh as the Dafla, Miri, Abor, and Mishmi Hills. Finally, we reach the outermost foothills, the Shivalik Range. Rising just 900 to 1,100 meters above the Great Plains, these are the lowest of the Himalayan ranges. They stretch the full 2,400 kilometers, but narrow significantly as you move east. Unlike the massive walls of rock to the north, the Shivaliks are quite fragile. In fact, between the Gandak and Teesta rivers, the range becomes highly discontinuous, having been heavily eroded and dissected by numerous fast-flowing streams. The environment of the Shivaliks changes drastically from east to west. In the east, high rainfall supports thick, lush forests. But as you move west towards Punjab, rainfall drops, and the southern slopes become barren, heavily scarred by seasonal torrents known locally as chos. The Shivaliks also have distinct regional identities, known as the Jammu Hills in the west, the Dang and Dundwa Ranges in Uttarakhand, and the Churiya Ghat Hills in Nepal. Nestled between the Lesser Himalayas and the Shivaliks are flat longitudinal valleys known as duns. Their formation is a fascinating story of blocked rivers. Long ago, rivers carrying heavy loads of gravel and sand from the high mountains deposited this debris, accidentally damming their own paths and creating massive temporary lakes. Over centuries, these lakes filled with sediment. Eventually, the rivers cut through the dams, draining the water away and leaving behind perfectly flat, fertile plains. The most famous and largest of these plains is Dehradun, which spans up to 45 kilometers in length.
While we call them dunes in the western Himalayas, the exact same geological features in the east are called duars. Found mostly around the foothills of Bhutan and West Bengal, the word duar literally translates to door, as these flat plains historically served as the primary gateways or passes into the steep eastern Himalayas.
Now let's travel to the far east, to the Provençal or Eastern Hills. Remember the eastern syntaxial bend we discussed? At the Dihang Gorge, the Himalaya snaps southward, forming a series of low hills along the India-Myanmar border. This region has a complex drainage system. Rivers in Nagaland flow into the Brahmaputra, while others in Manipur and Mizoram flow south into the Barak and Meghna systems, or east into Myanmar's Chindwin and Irrawaddy rivers.
The physiography here is incredibly unique. For instance, Manipur features a massive bowl-like topography, with the famous Loktak Lake sitting in the center, ringed by mountains. There is also a major geographical exception here, the Meghalaya Plateau, home to the Garo, Khasi, and Jaintia hills. Even though it sits in the northeast, it is technically not part of the Himalayas. It is actually a detached fragment of the ancient Deccan Peninsula, separated millions of years ago by the erosive power of the Ganga and Brahmaputra rivers.
The Purvanchal is made up of several distinct low hill ranges separated by small rivers, deeply intertwined with the lives of local tribes who practice traditional jhum cultivation. In the north, the Patkai Boom and Naga Hills act as the natural watershed boundary between India and Myanmar. Moving south past the Barel Range, we enter the Manipur Hills, and finally the Miso or Lushai Hills, where the elevations gently drop below 1,500 meters. To wrap up our look at the physical layout of these ranges, let's note the highest peaks in these northeastern states. Arunachal Pradesh is crowned by Kangto, while Nagaland's highest point is Saramati at over 3,800 meters. Manipur features Mount Tempu, Mizoram is home to the beautifully named Blue Mountain, and Tripura's highest point is Bedling Seep. We will carry this understanding of the terrain forward as we explore the regional divisions of the Himalayas next. Moving right along, let's dive into the regional division of the Himalayas, starting with the Western Himalayas. This vast section stretches from the Indus River in the west all the way to the Kali River in the east, covering a massive distance of 880 kilometers. It spans across three main administrative regions, Jammu and Kashmir along with Ladakh, Himachal Pradesh, and Uttarakhand. What is particularly notable here is that all three major parallel ranges of the Himalayas are clearly prominent in this western section. Let's look closer at the first subdivision, the Punjab Himalayas. This specific region is sandwiched between the Indus and Sutlej rivers, spanning about 560 kilometers. Because it mostly falls within Jammu and Kashmir and Himachal Pradesh, you will often hear it referred to as the Kashmir and Himachal Himalayas. The major mountain ranges you will find here include the Karakoram, Ladakh, Pir Panjal, Zanskar, and Daladar. Topographically, the general elevation drops as you move west, which dictates the drainage pattern. All the major rivers of the Indus system flow westwards right through this terrain. Focusing specifically on the Kashmir Himalayas, we find a complex series of ranges, namely the Karakoram, Ladakh, Zanskar, and Pir Panjal. This high-altitude environment is crucial because it houses some of the most important glaciers in South Asia, such as the Baltoro and the massive Siachen Glacier. Additionally, the northeastern edge of this region, known as Aksai Chin, is so dry and elevated that it functions as a high-altitude cold desert. Within the Kashmir Himalayas, the topography creates distinct valleys and requires specific mountain passes for travel. The famous Valley of Kashmir, along with the beautiful Dal Lake, is nestled right between the towering Great Himalayas and the Pir Panjal Range. To navigate these formidable mountains, several critical passes are used. Zojila cuts through the Zanskar Range, Banihal crosses the Pir Panjal, Fotula navigates the Zanskar, and Kardunla provides passage over the Ladakh Range. The Kashmir region is also incredibly rich in water bodies and holds immense cultural significance. It features major freshwater lakes like Dal and Wular, as well as high-altitude saltwater lakes such as Pangong Tso and Somoriri. The landscape is drained by the mighty Indus River and its key tributaries, the Jhelum and the Chenab. In fact, the city of Srinagar is built right on the banks of the Jhelum. Beyond its geography, this area is a spiritual hub, hosting famous pilgrimage sites like Vaishno Devi, the Amarnath Cave, and Chadar-e Sharif. Moving east, we enter the Himachal Himalayas. This section lies roughly between the Ravi River in the west and the Kali or Sharda River in the east. It is a vital watershed because it is drained by two of India's major river systems, the Indus and the Ganga. The Ravi, Beas, and Sutlej flow into the Indus, while the Yamuna and Ghaggar eventually join the Ganga. Structurally, the Lesser Himalaya here is represented by the Pur Panjal and Daladar ranges, while the Outer Himalaya is defined by the Shawalik Range. The topography of the Himalayas heavily influenced its historical development. The southern slopes facing the Indian plains are rugged, steep, and heavily forested, whereas the northern slopes are relatively bare and have a gentler gradient. The northernmost part actually extends into the Spiti subdivision, which is a continuation of the Ladakh cold desert. Because of the pleasant climate at altitudes between 1,000 and 2,000 meters, the British colonial administration developed numerous hill stations and cantonment towns here, including Dharamshala, Mussoorie, Shimla, and Ranikhet.
Next is the Kumaon Himalayas, situated entirely within the state of Uttarakhand, extending from the Sutlej to the Kali River. The valleys of the Greater Himalayas in this region are primarily inhabited by the Bhotias. The Bhotias are nomadic groups with a fascinating lifestyle. They practice transhumance. During the summer months, they migrate up to the Bugyals, which are lush, high-altitude summer grasslands, to graze their livestock, and then they return to the shelter of the lower valleys when winter sets in. The Kumaon Himalayas have distinct geological formations. Here, the Lesser Himalayas are represented by the Mussoorie and Nag Tibba ranges. Just south of the Mussoorie Range, between the Ganga and Yamuna rivers, runs the Shawalik Range. A major distinguishing physiographic feature of both the Himachal and Kumaon Himalayas is the presence of dun formations. Duns are essentially flat, longitudinal valleys that sit right between the Lesser Himalaya and the Shawalik Range. The most famous example of this is Dehradun.
Continuing eastward, we reach the Central Himalayas, which host the tallest peaks on Earth. Covering an 800-kilometer stretch between the Kali and Teesta rivers, this is where the Great Himalaya Range reaches its absolute maximum height. It features world-famous giants like Mount Everest, Kanchenjunga, Makalu, and Annapurna. In this section, the Lesser Himalaya is known locally as the Mahabharat Lek, and it is carved by major rivers like the Gaggara, Gandak, and Kosi. Nestled between the Great and Lesser Himalayas are the historic Kathmandu and Pokhara valleys. Noticeably, as we move further east here, the Shawalik Range starts to become discontinuous. Further east are the Eastern Himalayas, also known as the Assam Himalayas, stretching 720 kilometers from the Teesta River to the Brahmaputra. Because this region receives massive amounts of monsoon rainfall, the mountains show a marked dominance of fluvial or river-based erosion. The overall elevation is lower than in the Nepal section. The southern slopes remain steep, while the northern slopes are gentle. Interestingly, the Lesser Himalayas become very narrow and sit very close to the Greater Himalayas, and the Shawalik Range practically disappears. Finally, after the Diang Gorge, the entire mountain system takes an abrupt southward turn, becoming the Purvanchal Range. Within the eastern section, the Sikkim Himalayas have their own unique characteristics. This area is defined by fast-flowing rivers like the Teesta, deep valleys, and the towering peak of Kanchenjunga. Culturally, the higher reaches are home to the Lepta tribes, while the southern Darjeeling area has a diverse mix of Nepalese, Bengalis, and tribal communities. Geologically, the Shawalik formations are completely absent here. Instead, we find Duar formations at the foothills, which have been brilliantly utilized for developing expansive tea gardens. The region is also globally renowned for its scenic beauty and incredible biodiversity, particularly its wide variety of orchids. The easternmost section is the Arunachal Himalayas, extending from the Bhutan border all the way to the Difu Pass. Key peaks here include Kangtu and Namcha Barwa. The landscape is heavily dissected by fast-flowing rivers rushing from north to south, carving incredibly deep gorges. The most famous of these is the gorge cut by the Brahmaputra River just after it crosses Namcha Barwa. Because the topography is so extremely rugged, building roads between valleys is very difficult. Consequently, most trade and human interaction historically had to route down through the Duar region along the border with Assam. When we compare the eastern and western sections of the Himalayas, a stark contrast in their elevation profiles emerges. In the eastern section, the mountains rise abruptly from the plains of Bengal and Alv. They attain massive elevations over a very short horizontal distance, meaning giants like Kanchenjunga and Everest are surprisingly close to the flat plains. In stark contrast, the western Himalayas rise much more gradually. You have to travel through a long series of progressively higher ranges, meaning the peaks of perpetual snow are often 150 to 200 kilometers away from the plains.
Let's test our understanding with a question from the 2022 UPSC exam. You are asked to consider 3 pairs of peaks and their corresponding mountain ranges: Namcha Barwa with Garhwal Himalaya, Nanda Devi with Kuman Himalaya, and Nokrek with Sikkim Himalaya. You need to identify which of these pairs are correctly matched. Take a moment to recall the regional divisions we just covered.
The correct answer is B, 2 only. Let's break down why. Pair 1 is incorrect because Namcha Barwa is located at the far eastern edge of the Himalayas in Arunachal Pradesh, whereas the Garhwal Himalayas are in Uttarakhand. Pair 2 is correct. Nanda Devi is indeed located in the Kuman Himalayas of Uttarakhand. Finally, pair 3 is incorrect because the Nokrek Peak is actually the highest point in the Garo Hills of the Meghalaya Plateau, nowhere near Sikkim. Here is another related question, this one from the 2003 UPSC exam. It simply asks, Nanda Devi Peak forms a part of which Himalayan region? The options are the Assam Himalayas, Kuman Himalayas, Nepal Himalayas, or Punjab Himalayas. As we just discussed in the previous explanation, Nanda Devi is located in the Chamoli district of Uttarakhand, which places it squarely within the Kuman Himalayas. It is a highly significant peak, being the second highest in India after Kangchenjunga, and the surrounding Nanda Devi National Park is recognized as a UNESCO World Heritage Site for its ecological importance. So the answer is B. To summarize the ranges across the different regions, we can look at this breakdown. The Trans-Himalayas are mostly in Jammu and Kashmir and Himachal Pradesh. The Greater Himalayas, with an average height of 6,000 meters, span continuously across all regions. The Lesser Himalayas change names: Pir Panjal in J&K, Dauladhar in HP, Mussoorie and Nagtiba in Uttarakhand, Mahabharat Lake in Nepal, and various local names in the east. Finally, the Shivaliks, averaging 1,000 meters in height, are present in the west and central parts but disappear by the time we reach Assam and Arunachal Pradesh. Now, let's shift our focus to the important valleys nestled within these Himalayan ranges. Some of the most significant include the Kashmir Valley, trapped between the Greater Himalayas and Pir Panjal. In Himachal Pradesh, we have the Kangra and Kulu valleys. Uttarakhand features the Dun, Bhagirathi, and Mandakini valleys. Over in Nepal, the Kathmandu and Pokhara valleys are major population centers. It's worth noting that the Pokhara and Kathmandu valleys are highly vulnerable to earthquakes because they sit on loosely deposited clayey alluvium, which is prone to liquefaction during seismic events. The Kashmir Valley is perhaps the most famous of these, known for its beauty and unique geological history. Sitting at an average elevation of over 1,500 meters, it is a synclinal basin. Over millennia, it has been filled with a mix of alluvial, lacustrine, or lake deposits, fluvial, and glacial materials. The Jhelum River slowly meanders through these soft deposits before cutting a deep gorge through the Pir Panjal Range to escape. Because this gorge is a limited outlet for water, the valley is highly susceptible to severe flooding. A defining feature of the Kashmir Valley is the presence of kurewas. Kurewas are essentially massive, thick deposits of glacial clay, old lakebed sediments, and other materials that are embedded with glacial moraines, the rocks and soil left behind by ancient, moving glaciers. You will find them primarily in the Kashmir Valley and the Bhadrawa Valley. Visually, they look like large, flat-topped mounds bordering the edges of the valley. Scientifically, they are fascinating because they contain ancient mammal fossils and layers of peat, which is partially decayed vegetation. These kurewas formed over 1 million years ago during the Pleistocene period, when the entire Kashmir Valley was actually a massive lake submerged underwater. Eventually, tectonic or endogenic forces cracked open the Baramulla Gorge, causing the giant lake to drain away. The kurewas are the thick sediment deposits left behind. Over time, river action has carved them up, but they remain up to 1,400 meters thick in places. Economically, they are incredibly valuable today. The unique soil composition of the kurewas is what makes the cultivation of saffron, the high-quality local saffron, possible, alongside thriving almond, walnut, and apple orchards. Within the Kashmir Valley, we also find the Zabarwan Range. This is a relatively small mountain range situated between the Sindh and Litter River valleys in the north-central part of the main valley. If you've ever seen pictures of the famous Dal Lake or the historic Mughal gardens of Srinagar, you were looking at the Zabarwan Range in the background. It also hosts Asia's largest tulip garden. Ecologically, it is vital because it contains Dachagam National Park, which is the last refuge for the critically endangered Kashmir stag, also known as the Hungal. Moving to Himachal Pradesh, we find the Kangra and Kulu valleys.
The Kangra Valley is a strike valley positioned between the Daladar Range to the north and the Shiwalik Hills to the south, extending down to the Bias River. It is globally recognized for Kangra tea, which holds a geographical indication tag. The Kulu Valley, on the other hand, is a transverse valley located in the upper course of the Ravi, carved out by the Bias River between Manali and Largi. It is a major hub for tourism and is famous for its extensive apple orchards. You might be wondering about the terms strike valley and transverse valley that we just used. A strike valley is one that runs parallel to the mountain ridge, or perpendicular to the general downward slope of the mountain. Because it runs lengthwise along the range, it's often called a longitudinal valley, just like the Kangra Valley. A transverse valley, however, is formed when a stream cuts directly across the slope of the mountain, creating a valley that runs parallel to the slope's downward dip. The Kulu Valley is a perfect example of this cross-cutting formation. Let's turn our attention to the snow in the Himalayas, specifically the concept of the snow line. The very name Himalaya translates to abode of snow in Sanskrit. The snow line is the specific elevation marking the lowest level where snow remains year-round, perpetually. This line is not uniform. It varies significantly across different regions based on latitude, precipitation, and local topography. For instance, in the eastern and Kumaon Himalayas, the snow line sits high at around 3,500 meters, but in the Punjab Himalayas in the west, it drops down to about 2,500 meters. Why does the snow line vary so much across the mountain range? Latitude plays a role, as the range moves from 28 degrees north at Kanchenjunga up to 36 degrees north at the Karakoram. However, the primary factor is actually precipitation. The western Himalayas receive less overall precipitation, but what they do get falls mostly as snow from western disturbances. The eastern Himalayas get massive amounts of precipitation, but mostly as summer monsoon rain, which melts lower snow. Topography matters too. The snow line is actually lower on the southern slopes of the Great Himalayas compared to the northern slopes, simply because the southern side catches much more moisture and precipitation. Above the snow line, we find the massive glaciers that feed the rivers of the subcontinent. A glacier forms through the perennial, year-after-year accumulation of snow, ice, rock, and sediment. Over decades, the sheer weight of this accumulation causes the snow to undergo metamorphosis, turning into dense glacial ice that slowly flows downslope under gravity. The scale of glaciation here is staggering. A study by ISRO identified nearly 35,000 individual glaciers, covering over 75,000 square kilometers across the Indus, Ganga, and Brahmaputra basins. The Karakoram Range hosts the most significant glacial development in the entire region. The southern side of this range in particular features gigantic rivers of ice. In fact, some of the largest glaciers on Earth outside of the polar and subpolar regions are found right here. Notable examples include the massive Siachen Glacier, stretching 75 kilometers through the Dnieper Valley. There is also the Hispar Glacier at 62 kilometers and the Fedchenko Glacier in the nearby Pamirs, which measures an impressive 74 kilometers. In contrast, the Pir Panjal Range has a much smaller glacial footprint. The glaciers here are far fewer in number and significantly smaller in size compared to the giants of the Karakoram. To give you an idea of the scale difference, the longest glacier in the entire Pir Panjal Range is the Sonapani Glacier, located in the Chandra Valley of the Lahore and Spiti region. It measures only 15 kilometers in length, which is quite small compared to the 75-kilometer Siachen. Let's look more closely at the famous Siachen Glacier in Ladakh. Situated near the Karakoram Pass, it is a piedmont glacier, meaning it forms where valley glaciers spill out and spread into a flatter area at the mountain's base. It is a key part of what is called the Third Pole, the massive ice reserve of High Asia. Originating at Indira Col West, it is known geopolitically as the highest battleground in the world, enduring brutal temperatures down to minus 50 degrees Celsius. Hydrologically, it is vital as the source of the Dnieper River, which feeds the Shyok and eventually the Indus River. There are several other massive glaciers located in the Karakoram Range within Pakistan-occupied Kashmir. The Godwin-Austen Glacier sits close to K2, the world's second highest peak. The Biafo-Gyeong and Baltoro glaciers are crucial sources for the Shigar and Braldo rivers, respectively. The Hispar Glacier, which we mentioned earlier, actually converges with the Biafo Glacier at the high-altitude Hispar La Pass. Other significant ice masses in this rugged terrain include the Cordopin, Rakhiot, Diamir, and Trindro glaciers, all of which feed the complex river network of the Indus Basin. Finally, in the Zanskar Himalayas, we have the Machoi Glacier. Located in the famously cold Dras region of Ladakh near the Zojila Pass, this glacier plays a crucial role in the local hydrology. It acts as the source for two important rivers, the Sindh River, which flows into the Jhelum, and the Dras River. The waters from this glacial melt eventually combine to form the Suru River. We'll explore more about how these glacial melts feed into the larger river systems in the next section. Moving further into the regional characteristics of the Aranishal Himalayas, let's examine the immense water resources here. The region is drained by several important rivers, including the Kameng, the Subansiri, the Dihang, the Dibong, and the Loet. Because these rivers are perennial, meaning they flow year-round, and they navigate steep mountainous terrain with a high rate of fall, this specific area holds the highest hydroelectric power potential in the entire country. Beyond the physical geography, an incredibly important aspect of the Arunachal Himalayas is the human element. This region is home to numerous distinct ethnic tribal communities. If we travel from west to east across the region, some of the most prominent communities we encounter are the Monpa, the Dafla, the Abor, the Mishmi, the Nishi, and finally, the Nagas. Each of these groups has a unique cultural identity, deeply tied to the mountainous landscape. How do these communities sustain themselves in such rugged terrain? Most of these indigenous groups practice a traditional form of agriculture known as juming. You might also know this as shifting cultivation or slash-and-burn agriculture. While this practice involves clearing patches of forest for temporary farming, it's important to note that this region remains incredibly rich in biodiversity. For generations, this delicate ecological balance has been actively preserved by the indigenous communities, who understand the land intimately. Another major economic activity in this broader region is tea cultivation. The British originally introduced tea plantations here, strategically taking advantage of the perfect physical conditions. Tea requires very specific environments to thrive: moderate slopes that prevent waterlogging, thick soil rich in organic matter, consistent and well-distributed rainfall across all seasons, and mild winters. The lower hills of this region provided exactly that perfect recipe. Now let's zoom out and look at the broader significance of the entire Himalayan range, starting with its massive influence on the Indian climate. The Himalayas act as a giant climatic wall. During the summer, they intercept the moisture-laden monsoon winds blowing in from the Bay of Bengal and the Arabian Sea. This interception forces the clouds to release heavy precipitation across the Ganga Plains and the northeastern hills. Furthermore, the mountains physically direct these monsoon winds westward, toward regions like Punjab and Haryana. But the Himalayas don't just trap moisture in, they also keep freezing air out. They serve as a formidable shield, protecting the northern plains from the bitterly cold, dry continental air masses that sweep across Central Asia and Siberia in the winter. If this massive mountain barrier did not exist, the Indian subcontinent would look drastically different. Instead of our current climate, much of India would likely be a barren desert experiencing incredibly severe freezing winters. High above the peaks, the Himalayas also influence upper atmospheric circulation. They sit directly in the path of the subtropical jet stream, a fast-flowing ribbon of air high in the troposphere. The sheer height of the Himalayas physically splits this jet stream into northern and southern branches. This splitting effect is actually a critical meteorological trigger that helps draw the summer monsoons into the Indian subcontinent. To understand how crucial these concepts are, let's look at a question from the 2010 UPSC prelims. It asks, if there were no Himalayan ranges, what would have been the most likely geographical impact on India? The options suggest that the country would experience Siberian cold waves, the Indo-Gangetic Plain would lack alluvial soils, and the monsoon pattern would change. Let's break down each of these statements to find the correct answer. Let's evaluate the first statement regarding cold waves from Siberia. As we just discussed, the Himalayas are a massive physical barrier. They completely block the freezing, dry winds descending from Central Asia and Siberia during the winter months. Without this towering wall of rock and ice, those freezing winds would sweep right down into the subcontinent, plunging the northern plains into severe freezing winters. Therefore, statement 1 is absolutely correct. Now, for the second statement concerning the Indo-Gangetic Plain and its soils, the Himalayas are the birthplace of major river systems like the Indus, the Ganges, and the Brahmaputra.
As these rivers carve through the mountains, they erode vast amounts of rock, carrying it down as fertile alluvial soil and depositing it across the plains. Without the mountains, these rivers wouldn't exist. Furthermore, without the mountains altering the climate, this region would fall under the subtropical high-pressure zone, making it an arid or semi-arid desert, much like the Sahara. So statement 2 is also correct. Finally, let's look at the third statement about the monsoon pattern. The Himalayas act as a wall that forces warm, moisture-laden monsoon winds to rise, cool, and condense, resulting in heavy rainfall over northern and eastern India. If the mountains were removed, these winds would simply blow straight across the landmass without dropping their moisture, rendering the current monsoon pattern practically non-existent in the plains. Since all 3 statements are correct, the right answer to the UPSC question is option D, 1, 2, and 3. Expanding on the idea of rivers, the Himalayas are truly the lifeline of the subcontinent. The rivers originating here provide fresh water to nearly 500 million people in India alone. Because they are fed by both monsoon rains and melting glaciers, these rivers are perennial, guaranteeing a year-round water supply. Additionally, as these swift-flowing waters rush downward, they carry enormous amounts of mineral-rich silt, or alluvium, which continually replenishes and enriches the agricultural heartlands of the Ganga and Brahmaputra plains. This combination of steep natural topography and swift perennial rivers doesn't just help agriculture. It offers massive potential for hydroelectric power generation across the entire Himalayan range. Recognizing this, the government has constructed numerous hydroelectric power plants in these valleys. However, it is crucial to note that while this provides renewable energy, it frequently comes at a severe cost to the fragile local environment, disrupting ecosystems and local communities. The Himalayas are also a treasure trove of forest wealth, stratified by altitude. At the lower, warmer levels, you'll find dense tropical evergreen forests. As you move higher, these transition into rich coniferous and temperate evergreen forests, eventually giving way to hardy alpine vegetation near the snowline. These forests are vital to the economy, providing fuel wood and a vast variety of timber for industries. They are also natural pharmacies, housing countless medicinal plants, while the high-altitude grass patches serve as rich pastures for grazing livestock. When it comes to agriculture, the Himalayas present a tough challenge. The rugged, steeply sloped terrain means large-scale, flat-field farming is impossible. Instead, farmers have ingeniously carved terraced slopes into the mountainsides. Rice is the primary crop grown on these terraces, supplemented by wheat, maize, and potatoes. Additionally, as we mentioned earlier, the lower Shawalik hill slopes provide the unique microclimate required for extensive tea cultivation. Because traditional agriculture is difficult, horticulture, specifically fruit cultivation, has become a principal occupation for many mountain communities. The temperate climate of the Middle Himalayas is absolutely perfect for orchards. Farmers here grow a stunning variety of high-value fruits and nuts, including apples, pears, grapes, mulberries, walnuts, cherries, peaches, and apricots, which are then exported all across the country. The cool climate that supports these orchards also supports a massive tourism industry. While the northern plains bake in the summer heat, suffering under hot, dry winds like the Lu, the Himalayas offer a cool, comfortable refuge. This has led to the development of numerous famous hill stations like Srinagar, Shimla, Manali, Mussoorie, Darjeeling, and Gangtok. Furthermore, the increasing popularity of winter sports like skiing has transformed these areas into year-round destinations, bringing a rush of tourists even in the snowy months. Beyond leisure, the Himalayas hold immense spiritual significance, driving a massive sector of cultural tourism. The mountains are considered sacred and host countless ancient Hindu and Buddhist shrines. Every year, millions of devotees undertake arduous journeys to important pilgrimage sites, such as Kailas, Amarnath, Badrinath, Kedarnath, Vaishno Devi, and the sources of the holy rivers at Gangotri and Yamunotri. Deep beneath these sacred sites and tourist hubs lies a wealth of mineral resources. The geological history of the Himalayas, specifically the geosynclinal deposits found in tertiary rocks, means there are potential reserves of coal, peat, and even oil. We already know of coal deposits in Kashmir, alongside occurrences of copper, lead, zinc, gold, silver, limestone, and precious stones across the range. However, safely and economically extracting these resources from such a volatile, mountainous terrain requires highly advanced technologies that are still largely unavailable.
Despite the extraction challenges, geological exploration continues to yield massive surprises. In a groundbreaking announcement in February 2023, the Geological Survey of India established the presence of 5.9 million tons of inferred lithium resources. This massive deposit was found in the Salal Haimana area of the Riyasi district in Jammu and Kashmir. Because lithium is a critical component for modern batteries and electric vehicles, this single discovery instantly propelled India to become the 7th largest source of lithium globally. We'll continue exploring the geological formations that make such discoveries possible in the next segment.
Moving right along with our survey of Himalayan glaciers, let's look at some key glaciers in Jammu and Kashmir. First is the Changkumdan Glacier, situated on the lower slopes of the Karakoram Range. It is one of the sources that feeds the Shyok River. Nearby, also in the Karakoram Range near the Siachen Glacier, we find the Remo Glacier. This is the primary origin point of the Shyok River, which plays a crucial role in the region's hydrology.
Shifting to the Zanskar Himalayas, we have the Drung Drung Glacier, located near the Pensi La Pass. It is highly significant as the source of the Doda River, which is the largest tributary of the Zanskar River. Also in the Zanskar region is the Shafat Glacier, which feeds the Suru River, a major tributary of the Indus. Similarly, the Pensi Mungpa Glacier, found at the northwestern corner of the Zanskar Valley, also contributes its meltwater to the Suru River. Down in the Kashmir Valley, the Kolohoy Glacier stands out. Located near Pahalgam, it holds the title of the highest and largest glacier in Kashmir. It serves as the vital source of the Litter River, which eventually flows into the Jhelum River. Other notable glaciers in the area include the Tajiwas Glacier and the Harmukh Glacier, both situated in the Ganderbal district, with Harmukh located near the sacred Gangabal Lake.
Now, let's travel to Himachal Pradesh, where glaciers are locally referred to as Shigri. The Bara Shigri Glacier, located in the Lahal region, is the largest glacier in the state. It is the primary feeder for the Chandra River. When the Chandra River meets the Baga River at a place called Tandi, they merge to form the Chandrabhaga, which is more commonly known as the Chenab River. As a quick historical note, the ancient name for the Chenab is Askini.
Near the famous Rohtang Pass in the Pir Panjal Range, we find Bias Kund in the Kulu district. This glacial lake is incredibly important because it is the source of the Bias River, a major tributary of the Sutlej River. Not far from there, in the Lahore and Spiti Valley, lies the Chota Shigri Glacier. Like its larger counterpart, Bara Shigri, the Chota Shigri also contributes its meltwater to the Chandra River.
Moving to the Baralacha Pass in the Lahol and Spiti district, we have Suraj Tal, also known as Chokamtsi. The Baga River, which we mentioned earlier, originates from this high-altitude glacial lake. Over in the Kangra district's Pir Panjal Range is the Badal Glacier, the source of the Badal Nala. The Ravi River is actually formed by the confluence of 3 streams, the Badal Nala, the Rai Nala from the Rai Gar Glacier, and the Tantgari Nala from the Tantgari and Karu glaciers. The Lahal-Spiti region is home to several other significant glaciers. The Gangstang Glacier streams into the Shasha Nala before joining the Chenab River. We also have the Sonapani and Miar glaciers, with Miar being the source of the Miar River, another Chenab tributary. A particularly fascinating one is the Lady of Keelong Glacier. It gets its name from a distinct, dark, bare patch of rock in the middle of the ice that looks exactly like a woman carrying a heavy load on her back. Other glaciers in this region include Parad, Mukila, and Gora. In the Kulu district, the Duron and Parbati glaciers are crucial for the local river systems. The Duron Glacier feeds the Parbati River, which is a major tributary of the Bias River. The Parbati Glacier itself forms Mantalai Lake, the exact source of the Parbati River. Over in the Shimla district, Chandranahan Lake is a glacial lake that feeds the Pabar River. The Pabar flows into the Tons River, which ultimately joins the Yamuna River. Let's shift our focus to the state of Uttarakhand, starting with the massive Gangotri Glacier in the Uttarkashi district. It is the largest glacier in the Garhwal Himalaya and is famously known as the primary source of the Ganga River. It is fed by several tributary glaciers, including Raktavarn, Chatarangi, Satopant, and Kirti. The actual terminus or snout of the Gangotri Glacier is called Gomukh, which is the specific origin point of the Bhagirathi River. To understand the river systems here, we need to look at Devprayag. This is where the Bhagirathi River, originating from Gomukh, meets the Alaknanda River, which originates from the Satokant Glacier. Their confluence at Devprayag officially forms the Ganga River. All of this happens in the Garhwal region, a mountainous area bordered by Tibet to the north, the Kuman region to the east, Uttar Pradesh to the south, and Himachal Pradesh to the northwest.
In the Rudraprayag district, close to the sacred Kedarnath shrine, lies the Chorabari Glacier. This glacier is unique because it has two snouts. One snout serves as the source for the Mandakini River, while the other drains directly into a glacial lake called Chorabari Tal, also known as Gandhi Sarovar because Mahatma Gandhi's ashes were immersed there. Tragically, in 2013, a glacial lake outburst flood from this very lake caused the devastating Kedarnath floods.
Since we mentioned a gloth, let's define exactly what a glacial lake outburst flood is. As glaciers move, they erode the land and create depressions. When the ice melts, water fills these depressions, forming glacial lakes. The danger arises because these lakes are usually held back by unstable dams made of ice or loose sediment. If an earthquake, heavy rain, or an ice avalanche causes that fragile boundary to break, a massive, catastrophic volume of water is released downstream all at once.
Returning to Uttarakhand's glaciers, the Tipra Glacier in the Alaknanda Basin is the source of the Pushpawati River. This river is ecologically vital as it replenishes the groundwater that allows the famous Valley of Flowers, a UNESCO World Heritage Site, to bloom. Nearby in the Chamoli district is Hemkund's Lake, nourished by surrounding peaks. It is the source of the Lakshman Ganga and is culturally significant because Hemkund Sahib, the world's highest Gurdwara, sits right on its banks. In the Uttarkashi district within the Govind Pashu Vihar National Park, we find the Bandar Punch Glacier. It's quite unique because its meltwater feeds into both the Yamuna and Ganga river systems. The Bandar Punch Massif itself consists of three prominent peaks, Bandar Punch 1, Bandar Punch 2, and Kalanalk, or Black Peak. Just close by is the Yamunotri Glacier, which is famous as the source of the Yamuna River, the longest and second largest tributary of the Maibhi Ganga.
Also in the Bandar Punch Range, specifically in the Swarga Rohini Massif, is the Jaundar Glacier. This glacier is the source of the Supine River. When the Supine River meets the Rupin River, which originates near the Rupin Pass on the border of Uttarakhand and Himachal Pradesh, they form the Tons River. The Tons River is highly significant as it is the largest tributary of the Yamuna River, carrying more water than the Yamuna itself before they merge.
The Garhwal region is packed with other important glaciers. Bhagirath Karak is the source of the Uttar Ganga. The Katling Glacier feeds the Bilangana River, which flows into the Bhagirathi. We have the Bagini and Arwa glaciers located inside the Nanda Devi National Park. The Kedar Bamak Glacier in Gangotri National Park forms Kedar Tal Lake, the source of the Kedar Ganga. And the Panpatia Glacier is notable for geographically connecting the holy areas of Kedarnath and Badrinath.
Moving east to the Kumaon region of Uttarakhand, the Pindari Glacier is a major source for the Pindar River. The Milam Glacier feeds the Gauri Ganga, while the Kafni Glacier feeds the Kafni River. The Namik Glacier is the origin of the Ramganga River. The Mayalo Glacier is interesting as it merges with the Sona Glacier to shape the popular Panchachuli Glacier. Finally, the Kalabaland Glacier joins forces with the Yangchar and Sankalp glaciers to feed the Ralamgad River, alongside the Poding Glacier in the same region.
Let's travel to the eastern Himalayas, specifically Sikkim. Here we find the Zemu Glacier, the largest glacier in the eastern Himalayas, resting at the base of Kanchenjunga, the world's third highest mountain. It drains the mountain's eastern side and feeds the Teesta River. Speaking of the Teesta Kangse Glacier forms a glacial lake at its snout called Kangchungcho. It is from this specific lake that the Teesta River officially originates, initially known as the Chambo Chu. Also in Sikkim is South Lonak Lake, located in the far northwest. It is one of the fastest expanding glacial lakes in the region, which makes it highly dangerous. In fact, in 2023, a glacial lake outburst flood from South Lonak Lake caused disastrous flash floods in Sikkim. Lastly, for Sikkim, we have the Rathong Glacier, which is the source of the Rathong River. This river flows into the Ranjit River, which eventually joins the Teesta River. The shrinking of these Himalayan glaciers is a critical symptom of global climate change. Glaciers act as natural reservoirs, slowly releasing water to rivers like the Indus, Ganges, and Brahmaputra. When they melt too fast, it alters water flow patterns drastically. During monsoons, rapid melting combined with heavy rains can cause sudden catastrophic floods, like the 2013 Uttarakhand disaster. Conversely, because less water is stored as ice, river flows drop significantly during the dry season, threatening agriculture, drinking water, and hydropower. The loss of glacial ice also drives extreme weather events. Reduced snow and ice cover changes how sunlight is reflected, altering atmospheric circulation. This leads to more frequent and intense heat waves that threaten human health and crops. Furthermore, these atmospheric changes make the monsoon highly unpredictable. We end up seeing a harsh extreme, prolonged droughts in certain regions due to reduced rainfall, while other areas suffer from intense, concentrated downpours that cause flash floods and severe soil erosion. The fragile mountain ecosystems are also taking a massive hit. Shrinking glaciers disrupt the specific water regimes that local flora and fauna depend on. This leads to severe habitat loss and fragmentation, threatening sensitive, high-altitude species, for instance, contributing to the decline in snow leopard populations. Additionally, while the polar ice caps are the main drivers, the melting of Himalayan glaciers does contribute marginally to global sea level rise, adding to the long-term risks faced by coastal communities across the Indian subcontinent. Ultimately, all these environmental changes cascade into severe socioeconomic consequences. Reduced agricultural productivity directly threatens food security and the livelihoods of millions of farmers. As water becomes scarce and resources deplete, we see an increase in distress migration, with people forced to leave their homes just to survive. Furthermore, the combination of heat waves, floods, and subsequent waterborne diseases poses massive health risks. The retreat of these glaciers is a stark warning, showing how deeply interconnected our climate systems are with human survival, and leading us right into our next discussion on mountain geography. Let's examine the major mountain passes in the Himalayas. Because of the extreme elevations, a key characteristic of most Himalayan passes is that they remain closed during the winter months, typically from November to April, due to heavy and impassable snowfall. We will break these down region by region, starting in the northwest. Moving to the northernmost regions of Ladakh and Jammu and Kashmir, we find several strategic passes. The Mintaka Pass sits near the tri-junction of India, China, and Afghanistan. Just to its east is the Parpik Pass. The Kunjarat Pass is highly notable today because the China-Pakistan Economic Corridor, or CPEC, passes through it. Further east, we have the Agil Pass north of the K2 Peak, and the Karatagla and Karakoram passes, both of which historically served as vital offshoots of the ancient Silk Route. In eastern Ladakh, the elevations become truly staggering. Lanagla connects Ladakh to Tibet at the eastern edge of the Karakoram Range. Down in the Demchok sector, we find Emisla, but the crown jewel of high-altitude engineering here is Umlingla, which currently holds the record as the world's highest motorable road pass at 5,882 meters. However, this record will soon be broken once the road through Migla is completed, which will reach an astonishing 5,913 meters. Shifting to the Pir Panjal Range, the Bunny Hall Pass is a critical lifeline connecting Jammu to the Kashmir Valley. Historically, traffic went over the pass until the Jawar Tunnel was built underneath it in 1956. To further improve year-round connectivity, the 8.45-kilometer Bunny Hall-Qazi Gun Road Tunnel was opened in 2021 at a lower elevation, widening National Highway 44. Additionally, an 11-kilometer railway tunnel was completed in 2013, seamlessly linking Bunny Hall and Qazi Gund by train. Two other famous passes in Ladakh are Changla and Kardungla. Changla is the primary route connecting Leh to the stunning Pangong Lake, and it features a temple dedicated to Changla Baba, the pass's namesake. Kardungla, often celebrated by travelers, acts as the gateway to the Nubra and Shyok valleys. Historically, it was a major caravan route connecting Leh all the way to Kashgar in Central Asia. Looking at other routes in the region, the Pir Panjal Pass historically provided the absolute shortest route between the Kashmir Valley and Jammu. However, due to geopolitical tensions, this route has been closed since the partition of India. Further north, the Razdan Pass serves as the essential link connecting the main Kashmir Valley to the remote and beautiful Gurez Valley. The journey from Srinagar to Leh relies heavily on Zojila, a pass that connects the Kashmir Valley with the Dras and Suru valleys. Because it faces severe winter snows, the all-weather Zojila and Zimor tunnels are currently under construction. Moving towards the Zanskar region, Pensila connects the Zanskar Valley to Kargil. Finally, if you are traveling directly between Leh and Kargil, you will cross two major high-altitude passes, Fotula and Namikala. Moving south into Himachal Pradesh, we encounter Baralachala. This pass is a major bottleneck on the famous highway connecting Manali to Leh. It is also geographically significant because the Chandra and Baga rivers, which eventually merge to form the Chenab River, originate from its opposite faces. To improve travel times and avoid the harsh conditions of Baralachala, new tunnels are currently being constructed at Lachangla and Tanglangla. To travel between the lush Kulu Valley and the arid Spiti Valley, travelers historically used the Pin Parvati Pass.
This 5,319-meter pass is still actively used by shepherds from Spiti to bring their sheep to the green pastures of the Parvati Valley. However, the Depsa Pass, discovered much later, offers a significantly easier and shorter alternative route between Kulu and Spiti compared to the treacherous Pin Parvati track.
Perhaps the most famous pass in Himachal Pradesh is the Rohtang Pass. Located just 51 kilometers from Manali, it connects the Kulu Valley with Lahul and Spiti. For decades, Rohtang was notorious for massive traffic jams and winter closures. This changed dramatically with the opening of the Atal Tunnel, a 9-kilometer engineering marvel built directly underneath the pass, finally providing year-round, all-weather connectivity. Another transformative project is happening at Shingo La, which connects Lahal and Himachal to Zanskar in Ladakh. A new tunnel, the Shingo La Tunnel, is currently under construction here. Once paired with the existing Atal Tunnel, this new Padum-Darcher Road will create a completely new, all-weather alternative to the traditional Leh-Manali highway. Remarkably, this new route will reduce the driving distance between Manali and Kargil by a massive 522 kilometers.
The last major pass in Himachal Pradesh we will cover is Shipkila, which connects Shimla to Gartok in Tibet. This pass is geographically vital because it is the exact point where the mighty Sutlej River enters India from Tibet. Furthermore, it holds economic importance as one of India's 3 official border trading posts with Tibet, alongside Nathula in Sikkim and Lipu Lake in Uttarakhand.
Moving east to Uttarakhand, most passes here were part of ancient trade routes with Tibet that have largely remained closed since the 1962 war. However, they still hold immense cultural significance. The Lipu Lake Pass, located at the tri-junction of India, China, and Nepal, along with Mangshadura, are the primary routes used by pilgrims heading to Kailash Mansarovar. Other notable high-altitude passes include Mana Pass within the Nanda Devi biosphere, the ancient Niti Pass, and Muling La.
Seriously, in the eastern Himalayas of Sikkim, Nathula and Jelapla are critical passes. They connect Indian cities like Kalimpong and Gangtok directly to Tibet's Chumbi Valley, acting as historical arteries of the Silk Route. Just near here is the Doklam Plateau, a highly strategic area in Bhutan. You might recall this region from the news in 2017, when a major military standoff occurred between India and China as Chinese forces attempted to extend a road near the Doklamla Pass.
Finally, let's look at Arunachal Pradesh. The route to the famous Tawang Monastery relies on Bomdi La and the high-altitude Sela Pass. Further north, Boomla connects Tawang directly to Tibet, situated very close to the tri-junction with Bhutan. Moving eastward along the border, the Dihang and Yangya passes serve as additional remote crossing points, connecting Arunachal Pradesh to Tibet.
On the eastern edge of Arunachal Pradesh, the border shifts to meet Myanmar. The Daifur or Difu Pass is highly strategic as it sits exactly at the tri-junction of India, China, and Myanmar. Heading south along the Patkai Range, a series of lower elevation passes, including Kumjang, Pungang, Chaukan, and Pangsao, facilitate movement and historical trade across the dense forested borders between India and Myanmar.
To wrap up our comprehensive look at the Himalayas, remember that these mountain passes are much more than just geographic features. They are vital arteries for trade, pilgrimage, and military strategy. While the western passes in Ladakh and Himachal are seeing massive modern tunnel infrastructure to overcome extreme winter closures, the central and eastern passes remain heavily guarded, historically rich borders that define the geopolitical landscape of South Asia.